Hi, I'm going to show you how do you find the minimum value of a function. So let's assume you got a function y equals x squared plus 4x. So you can see the graph of this function, and as you can visually see, the function decreases, and then at -2, -4, the function increases again. So the minimum value of this function is at the point when x equals -2 and when y equals -4. And so you can visually see that. What I'm going to do is I'm going to show you a Python program wherein you will calculate this using a code. Okay, so I'll just clear my console. Alright, so if I run this code, so this is the equation. So that's your function, which is x to the power 2 plus 4x, which is the function which you were seeing earlier, x to the power 2 plus 4x. And this program, I'll just run it for you. When I run it, you can see the output of this program. This program shows the output that the function has the minimum value at x equals -2, and that value is basically y equals -4, which is what you can see visually. Okay, now I'm going to briefly explain you how it has been done. So the key to doing that is the derivative of a function. Now, what is a derivative of a function? So the derivative of function basically means the rate of change of the function with respect to a variable, and its standard formula is if you have got x to the power a function, and then if you wanted to calculate the derivative of this function d by dx x to the power a, then the answer would be a, so a comes in the beginning, times x to the power a minus 1. Right, so that's the standard formula. You can read more about the derivative of function at this link in Wikipedia. I'll post this link at the in the description as well. But if you just stick with this formula, and then so if you look at this formula, just make it smaller. Okay, so this is the original function, which is x to the power 2. The 2 star means x raised to the power 2 plus 4 times x. The derivative of this function would be d by dx of x to the power 2 would be, if you use this formula, what would be the d by dx of x to the power 2? It would be 2, because a is 2 times x to the power 2 minus 1, which is 2 times x to the power 1, which is 2x. So that's the first term, 2x, plus just stays as it is, plus, and then the d by dx of 4x would be, so d by dx of 4x would be, 4 is a constant number, so it comes out, so 4 times d by dx of x, or x to the power 1, it would be, because a is 1 here, so 1 times a is 1, so 1 times x to the power 1 minus 1, which is 1 times x to the power 0, which is x to the power 0 is 1, so it's basically 1, and then you multiply it by 4 because there's a 4, so d by dx of 4x basically is 4. So if you calculate the derivative of d by dx of x to the power 2 plus 4x, it would be 2x plus 4. You can also use some website like Wolfram Alpha, which you can see on the screen, to calculate the derivative. And as you can see here, I've entered the formula, and if you just click on it, then it will show you the derivative, which is 2x plus 4 if you expand the brackets. So don't worry too much if you don't really understand derivative. Just understand that derivative means the rate of change of function with respect to a variable. So in the Python code, we have calculated the function, and then we have calculated the derivative, and the important thing being done here is in this function, which is calculate gradient descent, and in this function as well, the most important lines are these two, which is line number 43 and 44. So what effectively we are doing is we are starting at a random point. Let's say we start at a value, we just assume that probably at x equals 0.02 the value is minimum. It could be any random point, so that's our starting value of x, and then we then we get the value of the gradient at that point, which is at 0.2. so dfx, and then we get a new value of the x, and the new value of the x would be x minus this formula, which is learning rate times gradient. And um, the implication of this is that we start at a random value of x, assuming that probably at that x, the value is minimum, and it doesn't matter what value you start. You could start at 0 as well, and it will give you the same result. So if I put start at 0 and run it, it will still give me the same result. Okay, so you start at any random value, and then each time you update your x, so basically in the direction of the gradient, so you slightly change the value of the x in the direction of the gradient, with the hope that that value of x may be the minimum value of maybe the point at which the function has got minimum value. So line number 43, 44 are the key, which is you are updating the value of x slightly using the formula x equals x minus learning rate times gradient. So that's the key, and the rest of things we are just to store the values, and there's some plots here to display the graphs in chart, but this is the most important. And yeah, I just show you with another one. So let's say if I slightly change the function, if I say 2x, okay, so now 2x has got the minimum value at if I say 2x square plus 4x, now this equation has got the minimum value at what point? At x equals minus 1, and the value of the y is minus 2. So if 2x square plus 4x, if I go and calculate the minimum for that, so I would show you how you do that. So if I comment it out, and my function is 2x square, right? So I say 2 times x squared. That's the only change I do here, so 2x square, and then because I have done 2 times, so I just have to run have 2 times here as well, because the derivative would be now 4x plus 4. And if I run it, you will see that the values that we are getting should be x equals minus 1 and y equals minus 2. So if I run it, you can see the new value here. So it says at the value x equals minus 1, the function has got the minimum value, and that minimum value is y equals minus 2, which you can visually confirm. So that's the program, and you can change the equations to verify that it is giving you the right answer. You can also change the starting value. It will still give the same answers. Probably you may have to do more iterations, right? You may change the learning rate as well. Learning rate is how quickly you change the value of the x, how sharply you change the value of the x. All right, so I've shown you visually how a graph looks like. Visually you can confirm what the minimum value is, and I've shown you a Python program with the key ingredients about how do you calculate it using a method called gradient descent. Thank you so much.